Hello guys, welcome to Introduction to Programming, and in this video I will give an introduction on what programming is all about and teach you guys the programming fundamentals that will apply to all programming languages. Also in this channel you'll find lots of tutorials related to programming where we will also do a bunch of projects, so please do subscribe. So these are the topics we will cover in this video, and I will also have separate videos where I will dive deeper into some of these topics. Links will be in the description. What is a computer? Computer help process, store, and retrieve data in a very fast and efficient manner. Early computers were created for the purpose of doing large calculations very quickly. The Electronic Numerical Integrator and Computer, or ENIAC, was the first general-purpose programmable computer available in 1945. Its main goal was to solve large numerical numbers, where it calculated artillery firing tables. It weighed about 30 tons and took the size of a small house and required several people to operate it. Computer in today's world are a lot more powerful and a lot more complex, and of course can pretty much fit on our hands now. Computer now require both hardware and software components in order to work. A basic computer consists of CPU, memory, storage, such as hard drive, communication devices, input devices such as mouse and keyboard, and output devices such as monitor. And in most computers, we are now seeing GPU as well, or graphic processing unit. You guys may have heard of chip shortages during COVID-19, and one of the biggest was GPU, where most people were using it for crypto mining. CPU is brain of the computer. Major two components of CPU are control unit and arithmetic logic unit, ALU. Control unit gives out commands that are to be carried out, and it works hand in hand with the ALU and memory. ALU is what executes the program instructions, and it performs four major operations: add, subtract, multiplication, and division. It also performs logical operations such as comparing values, that being if numbers are equal to, greater than, or less than to each other. Memory, or RAM, holds the data and instructions for processing. It is volatile, meaning it loses data on shutdown or when the program is done with it. It is one of the fastest ways of accessing data. Now, there's also something called registers that CPU uses, which hold instructions for even faster access. But I won't be diving too much into memory details in this video. A good analogy to picture all of this, which was also taught to me in school as well, was control unit is like the recipe that has step-by-step instructions on how to cook. ALU is the cutting board where the cutting or processing is done. Memory, or RAM, is like the extra space that is available on the counter for placing the ingredients there for faster access. And refrigerator is like the hard drive where we store the food. How programming works. Okay, so people who write code are called programmers, coders, or developers. Computers only understand binary, zeros and one, which is called machine language. On the hardware level, it's just a bunch of transistors that turn on and off. The combinations of these ones and zeros turn on these transistors, which sends electronic signals and help provide different outputs. Moore's law was introduced by Gordon Moore in 1965, and he said that about every 2 years, the number of transistors will double. This is one of the main reasons on why computers have gotten smaller, faster, and more efficient. However, sadly, this law is slowly dying, and one of the main reasons is a physical limitation. Transistors are already small and are approaching the size of atoms, so the number of transistors that can fit will soon be approaching its limit. Today's latest CPU contain about billions of transistors. The current standard size of these transistors is 7 nanometer, and experimental chips have shrunk to 2 nanometer. Intel recently unveiled a 100 billion transistor AI computer chip. To give an idea on how small that is, the size of a human strand DNA is 2.5 nanometer. It is said that our fingernails grows by 1 nanometer every second. Here's a picture of IBM's new 2 nanometer transistor under electron microscope. It is smaller than a human strand DNA. So, how does computer understand code? When we write code for a program or application, that is called the source code. The source code gets translated to assembly language by a compiler. From assembly language, it gets translated to machine code, zeros and one, and the code gets executed as binary code by the computer. Here's a diagram demonstrating the flow of high-level language like Java or C being translated down to machine language. Variables are a way of storing data in memory temporarily. They're stored in either heap or stack, which is part of RAM. Here's an example of variable declarations A, B, and C in Java, which is storing integer values. Now, I'll be diving more into details in a separate video on how variables are treated and stored in memory, and the ins and outs of it. Loops can be a very confusing concept for beginner programmers at first, but it isn't too bad. Loop, as the word itself say, is to run a block of code repeatedly. Like we say, just keep running around the loop. So we have three major types of loop: for loop, for each, and while loop. For loops are used to repeat a block of code X number of times. For example, if we want to print hello 3 times, we can write hello print statements 3 times. But if you want to print it 100 times, it can become messy and be cumbersome. We can write a for loop statement to print hello 100 times with 2 lines of code. Here's an example in Java on the left-hand side and Python on the right-hand side. Another type of loop is for each loop. This loop is used to iterate through all the elements in a list. Here's an example in Java and Python. While loop is a condition-based loop. It repeats until the statement is true. Here's an example of while loop. Again, I will have separate video on loops on my channel. Functions or method basically help us organize code. They generally perform a single related action. It helps encapsulate code, meaning hides away details from end user or developer. It also helps reduce redundancy. If we're calling a repeated code over and over again, we can wrap that into a function. Here's a small example of function that adds two number, both in Java on the left-hand side and Python on the right-hand side. Again, I'll be diving into detail in a separate video on the importance of functions and how to write them. Conditional statements are the most important aspect of programming. Computers are very smart, but also dumb. We need to give computer instructions on what to do, and it's just a bunch of if and else statements. Example would be if traffic light is red, car should stop, and if it's green, car should go. These statements either return true or false, and these are the basic building blocks for computer. Even AI and machine learning uses a bunch of if and else statements. When we want to check for multiple conditions, we have two main operators. First, it's logical AND, which basically checks if two or more value evaluates true. Second is logical OR, which states that either value must evaluate to true. Here's an example of if statement using logical OR, which compares and checks the statement of two variables, A and B. This will print error because the statement evaluates to true, since variable A is equal to 0. The right-hand side uses logical and this will not print error because variable B is not greater than 30,000. Again, I'll be diving into complete detail in a separate video on conditional statements, where I will also include something called switch statements. Data types define the type of data the programmer is using. Each data type has specific amount of size that it takes up in memory, so it is very important when building high performance and space efficient applications. The primitive data types defined in most languages are int, which takes in whole number, char, which takes in single character, float, which takes in decimal point numbers, and boolean, which takes in true or false values. Today, we have programming languages where we don't have to define types, such as programming languages like Python, and now even Java supports it. This is called dynamically typed, and it has its advantages and disadvantages. These types get resolved during runtime, versus statically typed, which gets resolved at compile time. During compile time, the compiler checks for type correctness, and if the type is not properly assigned, it will fail the build and throw an error, which is called compile time error. Runtime is when type is checked during execution of code, or when the program is running. I will dive a bit deeper into this topic in a separate video. Here's an example of primitive types in Java on the left-hand side, which is also statically typed. And on the right-hand side, we have Python, which is dynamically typed. In a separate video, we will see why data types are important and how we can create our custom data types as well. Data structures are a very important building block of programming. It helps us organize, store, retrieve, and process data. Some of the major data structures that are widely used by programmers are arrays, lists, hash maps or dictionary, tree, and graphs. Here's an example of array, list, and hash map in Java. Data structure is a big topic, and I will have separate videos on each of these data structures on my channel. Programming languages have really come a long way. There are hundreds of programming languages available now. When programming languages first started, they were quite complicated. Earlier, we saw how ENIAC was programmed, which required a bunch of people inputting codes. Later came assembly language in 1949, which was a bit higher than machine language. This is an example of a project I worked on where I used assembly language to program a microcontroller. You can see a simple division requires several lines of code and several instructions. Later came a few other programming languages like Fortran in 1957, COBOL in 1959. C language came in 1972, which was considered by many to be one of the very first high-level programming language and more human readable. It was also the backbone behind other languages such as C Sharp, Java, JavaScript, PHP, and Python. These languages were founded based off C. C++ came in 1980, which was considered to be one of the first widely used object-oriented programming. Python actually came in 1990, but it truly gained attraction in recent years due to it being one of the easiest language to learn and having ton of support and ton of frameworks for developing REST services, machine learning, and artificial intelligence. Java came in 1995 and is a very popular language whose motto is write code once and run everywhere, meaning it was able to run on any operating systems such as Windows, Linux, or Mac. In today's time, we have become more and more organized the way we write code and have different programming languages for different tasks. Just like for cooking, we have different utensils depending on what we're cooking. These are some of the popular backend languages. For front end, JavaScript is heavily used with these popular frameworks based off JavaScript. For mobile development, we have Swift for iOS development and Java and Kotlin for Android development. Testing is one of the most overlooked part of programming by developers. I've been guilty of that as well on some occasions. However, it should be considered an important part of programming. It allows us to decouple code, and what that means is that when we want to add new features and test the code, it becomes a lot easier. There are different types of testing listed here, and again, I'll be going into detail into each of these different types of testing in a separate video. So why is testing important? Ariane 5 explosion.
Décollage. Tous les paramètres propulsifs sont normaux et la trajectoire est normale.
In 1996, Ariane 5 rocket launcher exploded after about 40 seconds in air. What happened was a 64-bit floating number that basically gave information on whether the rocket was pointing up or down was converted to a 16-bit signed integer. As the rocket velocity increased, the 16-bit signed integer couldn't hold a 64-bit variable and threw an operational error, and it caused the rocket to self-correct by thrusting in wrong direction, causing a destruction. Now, there were several other factors that did play as well, but the main cause was this bug. So it is very important to test your code and to have all test scenarios covered. Another term you may hear is cover all the edge cases. Integrated Development Environment, or IDEs, are environments for developers who write or develop code. Gone are the days where people used to write code on Notepad and manually compile or build code via terminal. IDEs have made programming a lot easier and faster as they now provide a lot of tools for building applications quickly, ability to debug. They have IntelliSense, which help give suggestions and even autocomplete code. They have built-in compiler. So there are lots of IDEs available now for developing code in any languages. So the last topic I want to briefly cover is ethics. In every profession and life, we have to set standards on what's right or wrong, as these standards help shape our society. In Simmons' case, a contract programmer introduced a logic bomb, which is a malicious code that arises when certain conditions are met. This causes the program or application to malfunction, and contractor David Tinley purposely introduced a logic bomb, which forced Simmons to continue to rehire him. David Tinley faced max penalty of 10 years in prison. However, he served 6 months in federal prison and paid $7,500 in fine. Another major case was a Volkswagen case, where the software was used to deceive regulators in US and Europe on diesel pollution emission. The engineer was sent to prison for 40 months and had to pay a fine of $200,000. In addition, it also brought negative impact on Volkswagen reputation and spent roughly $25 billion to resolve claims from owners and buy back about 500,000 vehicles. Deepfake is another example of how software can be used in a negative way. Deepfake uses AI to mimic the movements of another person's facial expressions and even uses their voice. There are tons of deepfake software available on GitHub for open source community to use, mainly for entertainment purposes. But in future, this will become more sophisticated and can introduce serious threats. Here's a link for Association for Computing Machinery, which has a fine code of ethics and ethical principle, and has also been approved by IEEE as standard of teaching and practicing software engineering. I hope you guys enjoyed this brief introduction into programming world. This world has already been growing exponentially and will continue to grow even further. I will have lots of videos on my channel dedicated to programming and bunch of easy to follow tutorials and examples. Please do follow and subscribe. Thank you.